Hello children, in this lecture we will start our discussion from heading 3rd elimination reactions of alkyl halides. In such reactions, removal of hydrogen and halogen is taking place. That is why these reactions are also known as dehydrohalogenation reaction. In these reactions, alcoholic KOH used as a dehydrohalogenating agent, and the hydrogen which is removed in this reaction is placed at beta carbon atom. So removal of halogen which is placed at alpha and hydrogen which is placed at beta carbon atom is taking place simultaneously in the form of hydrogen halide. And due to the removal of hydrogen which is placed at beta carbon, such elimination reactions are also known as beta elimination reactions. Okay children, so you all know that elimination reactions are the reactions in which base compound is having different hybridization form of the central carbon atom than the product. Okay, and state of saturation of the base compound and product is also different. Okay children, so example which is given here, when ethyl bromide is reacted with KOH alcoholic, then removal of HBr is taking place and ethene is formed as a product, KBr plus H2O as byproduct. Now if isopropyl chloride is taken as a base compound which is reacted with alcoholic KOH, then formation of propene is taking place. Same way, in the case of tert butyl chloride, formation of isobutane is taking place with KCl and H2O. Okay, here order of dehydrohalogenation is given for the alkyl halide having same alkyl group with different halogen atoms. So on the basis of this order, you can see that the dehydrohalogenation of alkyl iodide is most easier, and same way for a different alkyl group, the dehydrohalogenation of tertiary alkyl halides is most easier. Okay children, then saytzeff rule. So according to this rule, if under dehydrohalogenation reaction of any alkyl halide, the possibility of formation of more than one alkene is there, then the alkene which is more substituted will form in major amount, and whereas the other alkene will form in minor amount. Okay, so this is the saytzeff rule, according which more substituted alkene will be formed in a greater amount. So example here, dehydrohalogenation of 2-bromobutane. So two alkenes are possible. One alkene will be formed due to the removal of this bromine with hydrogen from this carbon. Okay, so this alkene will form, and the second will form due to the removal of this bromine and hydrogen of this carbon. So this alkene will form. Okay children, so because two beta carbon are present with beta hydrogen atoms, so more than one alkene means overall two different alkenes will form. According to saytzeff rule, the first alkene will formed in major amount because it is more substituted than this second one. Okay, so how will you recognize that which alkene is more substituted? So the alkenes in which doubly bonded carbon atoms are having total comparatively less number of hydrogens will be known as more substituted alkene. So out of these two, you can see two hydrogen atoms are present here with doubly bonded carbon atom, and in this alkene there are 1 and 2, total 3 hydrogen atoms are present. So this will be less substituted, and that is why this will form in lesser amount than this one according to saytzeff rule. Okay children, then next heading, comparison of elimination and substitution reactions. So substitution reactions are of two types and elimination are also of two types, SN1, EN1. SN1 first order, elimination first order. Second order substitution, second order elimination. Okay, so the points which are given here, on the basis of these points you can differentiate between elimination and substitution reaction. So in the case of substitution, low temperature is favored, and for elimination high temperature is favored. Then second point, for substitution aqueous solutions which are more polar are favorable, but for elimination alcoholic solutions or non-polar solutions are favorable. Then third point, nature of nucleophile. So for the substitution, unhindered or sterically less hindered nucleophiles are favors, whereas for elimination sterically hindered nucleophile are favors. Okay, so for example, alkoxide ion and hydroxide ion. Okay children, so if we are using alkoxide ion is a stronger base than hydroxide ion. So when we use a stronger base alkoxide ion with tertiary alkyl halides, then mainly alkenes are formed under elimination reaction. Okay children, the next and last differentiating point is nature of alkyl halide. So this is the favored direction for alkyl halide, primary, secondary and tertiary. Okay, this is the order of the reactivity of alkyl halides for substitution reaction, and in the case of elimination reaction the order is the reverse of substitution reaction. Okay children, then we are moving to next type of reactions with metals. So the first reaction is here Wood's reaction. So in Wood's reaction, two molecules of a particular alkyl halide with sodium metal in the presence of dry ether form sodium halide plus related alkane. Okay, so this Wood's reaction is generally used for the ascending of carbon chain. Okay, so two molecules of methyl iodide are forming ethane, same way two molecules of ethyl bromide with sodium metal are forming butane. Okay children, so these are the examples. Now there is a one drawback of Wood's reaction. We cannot prepare alkanes with odd number of carbon atoms. Why? Because for that case we will require mixture of alkyl halides. Okay, mixture of alkyl halides. For example, if you want to prepare propane, so for the preparation of this propane, you will be require methyl iodide plus ethyl iodide, okay, with sodium metal. So you will require mixture of alkyl halides for the formation of this odd carbon containing alkane. So when you will take mixture here, then these two after reaction will form this alkane, but this and this molecule will also react with same molecules of their own which are present in medium. Okay, CH3I will react with other molecule of CH3I, and same way C2H5I will react with other molecule of C2H5I. So CH3 this alkane plus C2H5 this alkane will also form. Okay, so overall you will get a mixture of alkanes, and this is not easy to separate out these all alkanes from the product medium. So Wood's reaction is not used to prepare such alkanes which are having odd carbon atoms, because in that case a mixture of different type of alkanes will form, which is not easy to separate out. Okay children, moving to next page. Fitting reaction. So in fitting reaction we use aryl halides with sodium metal in the presence of dry ether. Okay, so biphenyl is formed as a product. The next is Wood's fitting reaction. In this reaction we can form alkyl substituted aromatic compounds. So for this we will use aromatic halide with aliphatic halide and sodium metal in the presence of dry ether. Okay, so then you will get corresponding alkyl substituted aromatic compound. For example, here in this example, phenyl bromide is reacting with methyl bromide and sodium metal forming toluene. Okay children, the next reaction with magnesium. So when magnesium is reacted with alkyl halides in the presence of dry ether, then alkyl magnesium halide is formed, and these compounds are the type of organometallic compounds and known as Grignard reagent. Okay, organomagnesium halides are known as Grignard reagent. For example, when ethyl bromide is reacted with magnesium in the presence of dry ether, then you will get ethyl magnesium bromide, which is an example of Grignard reagent. Okay, organometallic compounds, the compounds which are having a metal atom directly attached with carbon or alkyl group are known as organometallic compounds. Okay, so different type of organometallic compounds are given here, and alkyl magnesium halides, which we represent as RMgX, are known as Grignard reagent. Okay children, so these Grignard reagents are very important for a different type of conversions. Okay, here it is given that magnesium halogen bond is essentially ionic. So this is the charge separation in Grignard reagent. Alkyl group is partially negative, halide group is partially negative, whereas magnesium is partially positive in nature. So overall this compound is ionic in nature. Then next reaction of alkyl halides, and this is reaction with reactive metals. So alkyl halides react with lead and sodium alloy and forming tetraethyl lead. So this tetraethyl lead is used in petrol as an anti-knocking reagent. Tetraethyl lead. Okay, children. So tetraethyl lead is a important compound used as anti-knocking agent in petrol. Okay. So ethyl bromide when reacts with lead sodium alloy forming tetraethyl lead plus NaBr plus lead. Okay, so just this name and structure is important for you. Tetraethyl lead. Okay, children. So these are the chemical reactions of ethyl alkyl halides, and in these reactions we taken ethyl halide as an example in most of the type of reactions. Okay, children. After that, in our next lecture we will start with haloarenes. Okay, thank you.